All right, hey guys, that was kind of weird. So yeah, second half, or second part, I guess, of law of sines. All right, so we just talked about for a right triangle you use SOHCAHTOA, for a non-right triangle you use what's called the law of sines, and then in section 8.7 we're going to do the law of cosines. There is no law of tangent, but there's law of sines, law of cosines. Law of sines says sine of A over A equals sine of B over B, which equals sine of C over C. That's a capital C. And I said that you will only ever use two of them at a time, okay, and set them up as a proportion. So maybe you you use the B's and the C's, or you use the A's and the B's, right? You're only ever setting two of them equal to each other. What's the difference between capital letters and lowercase letters?
Capital letters are angles.
Capital letters are angles, so these guys are all angles. Angles. You don't necessarily have to write all this down if you know this already. Lowercase letters are the sides. Yep, the lines. So capital letters, angles, lowercase letters, sides. That keeps it pretty well, makes sense. One other thing that I will say, so let's say this triangle is labeled A, B, C like this, okay? Where is little a located, if that's my triangle? Like, yeah, technically it's not the hypotenuse because it's not a right triangle, but that's where little a will be located. How do you know that?
Because it's across.
It's across from the angle A, okay? Where is little b located? The bottom side. Little c is this side. So that's kind of how you know for sure where those are located. Okay, happy with that? All right, let's go down and example 3, I'm going to get rid of the instructions where it says determine whether each triangle has no solutions, one solution, or two solutions, then solve the triangle. We are only going to solve the triangle and not worry about all that other junk. So when it says solve the triangle, that means solve for everything that's not already there, right? So I'm just going to list out everything and we'll fill in what we have and what we need. We have angle S, we have angle R, we have angle T. And then we have lowercase s, lowercase r, lowercase t, and these are all the sides, okay? So 3 pieces of information we will know, and then we're solving for the other 3. Okay? All right. Which angle do we know?
R.
We know angle R is 105, okay? And then what is 9 representing? Little side r, right? That's 9 because it's the opposite of angle R, okay? What about 6? Little s is 6, right? Okay, now the only way that this can work for the law of sines to happen is if we have one group where we know the side and the angle, right? So do we have that happening here? Do we have the side and the angle for one of these? For like one of them, right? Look at the r's. We have both r's, right? We have our side and our angle. We have that. We have to use that, okay? So when we're setting up our proportion, we're doing the law of sines. We do sine of something over something, right? And we do the sine of the angle. So we're going to do sine of 105 over, what do we put it over? 9 equals, okay? Now the only other piece of information that I have is 6. But when I set it equal to, where does the 6 go? On the bottom, right? That's my side. So here I have sine of X or question mark. That's what we don't know. So this one's a little bit trickier than what we did on Thursday or Friday whenever we did the first half of this, is because we're solving for an angle here, okay? So there's one little difference that we have to do, but we still cross multiply. So we're still doing this proportion and we're going to cross multiply. So I'm going to multiply those together. 6 times sine of 105, that's what I'm going to do first, is equal to, what will this look like when I write it out? 9 times sine of x or sine of question mark or whatever you want to label it as, right? 9 times sine of x. Okay. Now, I'm trying to solve for x in here. So what do I have to do first? Divide by 9. Yeah, to get the 9 to go away. So divide by 9. All right. This stuff right here. Somebody type that into your calculator and see what you get. 6 times sine of 105 and then divide by 9. Okay, and if you type it in all at one shot, make sure you close the parentheses on the 105 before you divide the 9. Otherwise, it's going to give you a weird answer. Okay. What you got? 0.64. Okay, that sounds right. But that's not what x is. That's what sine of x is, right? Now, how do we get the sine out of there?
Do the reverse thing.
Yeah, you can't divide by sine because there's not sine of anything. A lot of people say like divide sine over, don't write that down, okay, because that's not right. We can't divide sine. We do the inverse sine, which is like that -1 thing. So we do inverse sine of that thing. Now, if you have it typed in previously, if you got the 0.64, blah, 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 don't retype 0.64, use the answer button. So do inverse sine of the answer. You see what I said? You see? Okay, go back up. Oh, you can't go back up. Okay, so I'm gonna do 6 times sine of 105. Is it 105?
Yeah.
Okay, divided by 9. I'm gonna do that. And then, so that's that number, okay? And then we're going to do, where's the numbers button? Shift sine, okay, of the answer. So it's not going to use the rounded number, it's going to use the actual full long decimal answer. Hit enter and tell me what you get. 40.09, okay, but they say anytime you're rounding angles, you round to the nearest degree, and any sides are 1 decimal place. So we're going to round this to 40 degrees, but which one did we just solve for? Out of those, we were either solving for S or solving for T. Which one do we solve for? The big S, right? So that one's 40 degrees, okay? Rounded to the nearest degree, 40.08. We got 40 degrees. Do we see how that works? Okay, now what do we want to solve for? What can we do next? Like out of this whole big chunk right here. What can we find next?
The angle.
Yeah, we can solve angle T really easily, actually, because these all have to add up to be 180, right? Okay, so if I add this together and subtract from 180, you get like 35 degrees. That's perfect. Beautiful. Okay, now we can use the law of sines again to solve for side T. Okay, now let's address one thing really quick. Okay, we have this going on here, and we're solving for angle T, or side T. Can I use the Pythagorean theorem? Because I'm solving for one of the sides. Can I do that? Like a squared, b squared, c squared, right? Can I do that?
Yeah, I don't think so.
How's come?
Because it's not a right triangle.
It's not a right triangle. So that's the kicker. Don't try to use that because it won't work. A squared, b squared, c squared does not work when you're solving for that. It looks like it might, because like this looks like the longest side, but because it's not a right triangle, we can't do that. We have to use the law of sines instead. Okay? So, where do I want to do this? I'm running out of room. I'll do it right here. Okay, so we have to have a fraction, like something over something equals something over something. We have sine of whatever and sine of whatever, okay? So, now we really have 2 groupings that we know. We know 40 and 6, and we know 105 and 9. Which one would you like to use?
40.
It'd be nice if we could use 40 and 6, but
Oh, but it's rounded.
40 was the rounded number that we got. So even though 40 and 6 might be like nicer numbers, we still need to use the 105 to be the most accurate. So we're going to use 105 and 9 just like we did before. Now we're doing sine of 35 over t, because that's what we don't know, right? And now we're just cross multiplying and dividing like normal, right? Okay, so I'm going to multiply these guys together. That is 9 times sine of 35 equals t times sine of 105. And then how do I get t by itself? Divide by sine 105, okay? So divide by sine 105. And because we're just solving for t, we don't have to do that extra step where we're doing the inverse. We just literally type this chunk into our calculator, and that's what we get, right? 9 sine of 35. Make sure you close the parentheses on the 35 and then divide by sine of 105. T is equal to something. 5.34, so 5.3. All the sides we're going to do 1 decimal place. All of the angles will go to the nearest whole number, right? So 5.3. Okay, one more thing. I didn't tell this to the first period class, but this is really good to note, right? Check this out. Check out our relationship. Which one's the biggest angle? Which one's the biggest side? R. Which one's the smallest angle? T. Which one's the smallest side? That should always be the case, right? The small one goes with the small one, the big one goes with the big one, the medium one goes with the medium one, right? Like there's a relationship between those guys, okay? That has to be the case always, right? So you can kind of look at your answer when you're done with it and like say, maybe I screwed up because the smallest one won't go with the smallest one, right? Okay, so there's kind of how that works. All right, we're going to skip B and C. We're going to go down to example 4. And they're not going to ask me to solve for everything here. They're just going to ask me to solve for one thing. But it says a baseball is hit. Where did I go here? We're making him dizzy. We're making him real dizzy. Okay, a baseball is hit from right here, and the baseball goes to, I need to quit touching the screen. It is caught over here where the person B is standing, okay? How far away from second base will the ball be caught? So they're asking me to find this distance right here, right? That's like my X, that's what I'm solving for, okay? Makes sense? That's what we're solving for. How far from where it's caught to second base is that ball? Now, we can't use SOHCAHTOA because this is not a right triangle. We have a 43-degree angle. We have a 65-degree angle, right? Okay? Now, here's the deal. When you use sine, cosine, or the law of sines, when you use the law of sines, the side that you're looking for has to be opposite from the angle, like they have to be opposites from each other. So I have to use 43, right? So I'm doing sine of 43 over x at some point equals. And then I have to know some other things. But the only other things that I know is I know that this angle is 65 and I know that this is 90. Is the 65-degree angle opposite the 90? No. So if I'm going to use 65, I would have to know this thing, right?
Mm-hmm.
Like that side.
So just find the angle.
What angle?
B.
B, that's a really good idea. So she says find this angle right here because we know that this one's 43 and this one's 65 and we can add those together. 43, 65 is 108 and that's subtracting from 180 is 72. So this is 72 degrees, right? And that is opposite the 90, right? So they have to be opposites each other. So we're going to set that equal to sine of what? 72 over the 90. Okay? Now, just so that we're clear, 72-degree angle was opposite from 90. My 43-degree angle should be opposite something. What is that guy going to be, like, guesstimation-wise? Probably less than 90, right?
Yeah.
If my 72-degree angle gave me 90, 43 should give me something less than 90, right? Okay, so let's cross multiply and divide. We have this multiplied together, so 90 times sine of 43 is equal to, this guy will be x times sine of 72. And we divide by sine 72. And we don't have to do the inverse because we're not solving for an angle, so here is x. And we have it equal to this junk right here, and we just plug it in and solve. 64.5, I think it's in feet. 64.5 feet is how long we caught it from second base. Okay? Good? Happy with that? The only time you do the inverse sign is when whatever you're solving for is like inside of the sine function, right? Then you have to do the inverse, okay? Otherwise, you can just cross multiply, divide, and you're good to go. Okay? Happy with that? All right, so I told you to do some homework problems on Monday. Not Monday. Friday or Thursday, something like that, Friday, okay? So on skills practice, you were supposed to do 1, 2, 7, and 8. I'm going to add 9 to that, okay? But you do not have to do 13 through 16. So none of those in the bottom. So just those top 5 on skills practice, okay? These top 1 and 2, I think we did number 2 together, but the formula for area, which we did not talk about today, we talked about that on Friday. Formula for area was 1/2 BC times sine of A, right? 1/2 BC sine of A. That was the formula for area. Now, it doesn't have to be angle A, but B and C have to be the sides that touch, sides touching the angle or adjacent to the angle, okay? So like B and C, angle A, this guy right here is 155. 6 and 10 are the two sides that it gives to me. Are those two sides touching my angle?
Yeah.
Yes, so those would go in for B and C. Like 6 and 10 would go in for B and C, and then I would do sine of 155 would go in there. That's the formula for area of those triangles, okay? So that's what you're going to do for those top ones. on the back side. So you're doing 1 through 9, which is really only like 1 through 5. I don't know where my 3, 4, 5, 6 went. But anyway, on the back side, kind of the same type of thing. Do 1, 2, 3, 4. You should have done 5 already, and 6, but you can skip the bottom. Okay, so just the triangle-y ones on each side. And there is that. I will caution you, like number 4, Jake Hodson was asking me because he was doing this one in class. He ended up with something weird, like I don't remember if it was like 93 degrees or 95 degrees or something like that for this angle. And he's like, that does not look like a 95-degree angle or whatever. Mm-hmm. Don't go by what it looks like. Just go by what you got. Okay. So be careful because some of these triangles look like right triangles, but they're not, or, you know, like the angles don't look the way that they're supposed to look. So be careful. It's fine. They're just trying to trick you. Okay. You'll end up with some weird things. All right. Happy with that? That's it. So those 6 and then those 5. That's all you have to do. Okay? All right. Goodbye, people in the video.